Hello ladies and gentlemen. For math today we're going to be looking at a video for lesson 1-11 and this is called Reasonable Answers. To be reasonable just means that it is not too far-fetched, it is not clearly wrong. So by the end of this lesson you will be able to estimate sums and differences of fractions and mixed numbers to decide whether your answer is reasonable or makes sense. An estimate is a number that is close to the actual amount, but it is not exact. So math mistakes can often be avoided simply by going back and asking yourself, does my answer make sense? If you think about it and you picture it in your mind, make a mental image, a lot of times we can figure out that our answer would not even be reasonable just by picturing that image. So what we use is something called fraction benchmarks. And remember that fraction benchmarks are reference points on a number line that we'll use to compare and plot other points. Fraction benchmarks are usually those points on the number line that are easy for us to work with and they're easy to picture in our mind. So on this screen you can see a number line and it has the points 0, 1/2, and 1. 0 you can think of as 0 halves, 1/2 is 1 out of 2 equal parts, and for 1 you can also think of that as 2 out of 2 equal parts. So I want you to just pause the presentation for a second and turn to the people that you're working with or a neighbor and have a conversation about the question, how could we use this number line to find the benchmark closest to 5/8. So that question is right here. How could we use this number line to find the benchmark fraction that is closest to 5/8? What I mean by that is it closest to 0, 1/2, or 1 whole? So pause the presentation now, talk to a friend or a neighbor or your group, and then when you're done having that conversation, come back and unpause the video. Okay, so you had a chance to talk to some other people about the question, how we could use the benchmarks 0, 1/2, or 1 whole to find where 5/8 is on that number line. So there's a couple of different ways to do this. One way would be to divide the number line into eighths and then label the eighths. So the number line right now is just split into halves. So if I want to split it into eighths, first I could split each half in half, and that gives me 4 equal size pieces. So since I want to get to 8, I need to 2-split each of these pieces here. Now I have a total of 8 equal size pieces, and I would number the, I would label the number line. 1/8, 2/8, 3/8, 1/2 is the same as 4/8, 5/8, 6/8, 7/8, and 1 is 8/8. On my number line now I can plot 5/8 right here, and it is easy to see then that 5/8 is definitely closest to 4/8 or 1/2. Another way would be to rewrite the benchmarks as eighths. So without actually splitting the number line into 8 equal size pieces, I could just rewrite 0, 1/2, and 1 whole as fractions out of 8. I know that 0 would be the same thing as 0/8 because I have none of them. I also know that 1/2 is equal to 4/8 because 4 is exactly half of 8. And 1 whole, well, that is 8/8. Any whole number is just a fraction written with the same numerator and denominator. So if I were to plot 5/8, I know that it would be just after 1/2, so its closest benchmark still is 1/2. So now we have 2 ways to compare, and we have found that 5/8 is closest to 1/2. Knowing how to do this will help us to determine if our answers are reasonable when we solve math problems. So let's take a look at an example. think about how you can use estimation for finding the sum of 3/8 plus 5/6. What we want to know is, should our answer be closest to 0, 1/2, or 1 whole? And now we might have to adjust our number line and think of that as, for example, 1, 1.5, or 2 whole, depending on what it is that we are adding or subtracting. So when I look at, when I look at 3/8 plus 5/6, the first thing I realized is that 3/8 is very close to 4/8, and I know that 4/8 is the same thing as 1/2. So I would say that 3/8 is about 1/2. I also know that 5/6 is only 1/6 away from a whole, so I might estimate that to be 1 whole. So now I know that my answer should be pretty close to 1 plus 1/2 or 1.5. So when I solve the actual problem, 3/8 plus 5/6, I want to make sure that it's reasonable by being somewhere near 1.5, and that does not mean that it's going to be exact. So first I have to find my common denominators, like always. I know that 6 does not go into 8, but I do know that 8 and 6 share a common factor, so my best denominator can be found by listing the multiples and finding the least common multiple. I'm going to go ahead and actually write this step out right now. I know 8 times 1 is 8, 8 times 2 is 16, 8 times 3 is 24, and I also know I can stop there because I know that 24 is a multiple of 6 as well, so I would find 24 in the 6th row. So I can write my new fractions with a denominator of 24. 8 times 3 gave us 24, so I'll multiply the numerator by 3, and that gives us 9. 6 times 4 is 24, so I'll multiply the numerator by 4, and that gives us 20. Now when I add, I have 29 24ths. I know I can make another whole number there because it takes 24 24ths to make a whole, and that would leave us with 5 more 24ths. That can be rewritten as 1 and 5 24ths. Now we estimated that our answer should be about 1.5. 1 and 5 24ths is a little bit less than 1.5 because I know that half of 24 is 12 and I only have 5, but that's where that word about comes in and is really important. My answer is greater than 1, and it's not greater than 1.5, it is not greater than 2, so at least it's somewhere close to 1.5, and that's reasonable. Does that mean for sure my answer is correct? No, not necessarily, but at least it is not too far-fetched to be wrong. So here's another example using subtraction. We're going to estimate first so that when we solve, we know that we'll be able to figure out if our answer is even in the ballpark, if it's even close. I know that 15/16 is only 1/16 away from a whole, so I'll estimate that as 1. And I know that 1/3, well, 1/3 is actually right in between 0 and 1/2. But to make it a little bit easier, I think I'm just going to refer to that as 1/2 because it's pretty close. So my answer should be somewhere around 1/2 because 1 minus 1/2 is 1/2. Now we'll find the exact answer and hope that it is somewhere near 1/2 in order to be reasonable. So let's see. Does 3 go into 16 evenly? No, it does not. So 16 is not my common denominator. Do 3 and 16 share a factor other than 1? No, because 3 is prime. The only factors of 3 are 1 and 3. 1 wouldn't count, and we already said 3 doesn't go into 16. So I am going to use product of the denominators. If you have to go off to the side to solve 16 times 3, go ahead and do that. 6 times 3 is 18. 3 times 1 is 3, plus 1 is 4. So my new denominator will be 48. I know that I multiplied 16 by 3 to get 48 because that's the other denominator. So I will do the same thing to my numerator. And 15 times 3, well, let's see, 15 times 2 is 30, plus another 15 would be 45. And then I know I multiplied 3 times 16 to get 48 because that was the other denominator. And 1 times 16 is 16. Now when we subtract 45 minus 16, we get 15 minus 6 is 9, and 3 minus 1 is 2, so we get 29/48. I know that this has got to be pretty close to 1/2 because it reminds me a lot of 25/50. Both of those numbers are close, and I know that 25 is half of 50. So it doesn't guarantee that we didn't make a mistake. It doesn't guarantee that our answer is correct, but it does tell us that at least we're close. So if we weren't anywhere near 1/2, we would go back for sure and do this problem again. It is always important to check your work. So what I'd like you to do right now is to solve this problem on your whiteboard. You can work with your friends or neighbors. And then I want you to mentally estimate the sum by rounding each of these mixed numbers to the nearest whole number. So hopefully you had a chance to go ahead and do that. And right now I am going to do that here on this page. 2 5/6 plus 7 1/8. I'm going to start off with my two little equal signs, and then so I don't forget, I'll put my whole numbers, 2 and 7. I know that the best denominator between 6 and 8 is going to be 24. Multiplied 6 by 4 to get 24, so when I do the same thing to the numerator, I get 20/24. I multiplied 8 by 3 to get 24, so I'll do the same to the numerator there, and I get 3. Now when we add, we get 23/24, and 2 plus 7 is 9. 9 and 23/24. Well, 23/24 is only 1/24 away from the next whole, and so that would be really close. Approximately, that squiggly equal sign is approximately equal to 10. Now when I go back and I look at the mixed numbers that I added together, 2 5/6, well, 2 5/6 is only 1/6 away from the next whole number, which is 3, plus, and then 7 1/8, well, that's only 1/8 past 7, so it's pretty close to 7. 3 plus 7 is equal to 10, so I know that I should have an answer that is about 10, and I do, so I have used those benchmarks to check to see if the answer is reasonable. And this slide is just another explanation to what I just said on the previous slide. So if you want to take a second and read this to yourself. And that is how we can use estimates and benchmark fractions to decide if our answer is anywhere near the answer that we were supposed to get or the answer we got, to know if we have to go back and redo our work or not.